So, do black holes ever actually evaporate? I don't know. Apparently, there's some Hawking radiation or something involved. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper Rulial Turtles All the Way Down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
So, full disclosure, this is actually a MacBook Pro. We want to be open and transparent, well, as much as we can. But I guess what's going on memes here. So, apparently, according to the late Professor Stephen Hawking's work, black holes evaporate. He has this fancy equation, which is almost exactly very similar to the equation for the Unruh effect. Real life is stranger than fiction, in my opinion. So what's going on here? All right, there's an article from Forbes. Links are in the doobly-doo. Ask Ethan. Do black holes actually evaporate? Nothing in the universe lives forever. All the stars is like 4 years old. All the stars that ever form will someday burn out. Distant galaxies and clusters of galaxies get pushed away from one another by dark energy. Even the stars within a galaxy on long enough timescales will get gravitationally ejected. It's very sad. Hopefully we have some time. Maybe we peace out when Andromeda. I'm just saying we don't. Apparently there's a very large magnetosphere that seems to be kind of like a croissant and whatnot that seems to protect us from a lot of different, let's just say, cosmic rays and other things that would probably wipe us out. I'd say we're very blessed. Now, just what is Hawking radiation? Science Press articles keeps referring to the electron-positron virtual pair produced at the event horizon, which makes a layperson think that Hawking radiation consists of electrons and positrons moving away from the black hole. As discovered by Stephen Hawking in 1974, black holes eventually evaporate. This is the story of how. So basically, the first thing you have to think about is what is empty space truly is. Imagine emptiness as best you can. What would you remove? You can take all the particles out for stars. Any matter, antimatter, photons, radiation, and anything else you can imagine must all go. You need your space to be devoid of any quanta that could be present. You won't be empty. You also have to shield your empty region from the influence of anything outside it. Oh, I think we're doing a Duncan experiment. Basically, it's a thought experiment, because apparently this isn't actually the case. No electric, magnetic, or nuclear fields or forces should be allowed to penetrate it. Exactly. We're thinking about what could happen. Even the gravitational influence of everything else in the universe would have to be removed. That includes the curvature of space induced by any and all masses and all forms of energy, as well as any gravitational waves or ripples in space-time that could pass through the space. Almost sounds like we need to become two-dimensional there. Just my conjecture. In our physical reality, we can't actually do this. But in theoretical physics, we can imagine it. Imagine a region of space with nothing influencing. Basically, okay, yeah, I think I totally stole that for some different things before. But essentially, there's fluctuations within the vacuum. So it's not. I kind of think of it as there's no true Irishman or Scotsman. I apologize. I think I'm both those things. I believe it allows me to get away with saying that. But is there no true vacuums? At least as far as we can do right now, and that if there's always energy, here's the whole point of my conjecture. And we have over here Hawking radiation again. It kind of goes through a lot of the same things. I tend to really disagree. I believe there's a singular point. Personally, in my opinion, it's literally a mathematical 0, 0, 0, 0. Why? Because that's what it is in matrix theory, I'm pretty sure. I don't know. Or at least that's essentially the balance point of the hyperbolic figure eight knot. Basically, everything goes around it. Mobius twist can explain a lot. Gamma function totally helps. I'm just saying, I feel we should use it more in physics. At least that's what the vibe I was getting from a lot of really smart people. But it's from Perimeter. I totally haven't read this. But no, there's been a lot of good work. I believe Professor Lee Smolin, I believe he's a director over there. But okay, what is Hawking radiation? Go to our friend Wolfram Alpha. Okay, so if we're going to assume the black hole radiate power, it's a mass of 10 to the 30 kilograms. How the heck much is that? We click the thingy. It's a comparison. Oh, That's a little over half the mass of our star. It's a lot of Earths. So that's a pretty small black hole. Total radiated power, 8.904 times 10 to the negative 28 watts. I have no idea what that is. That's power. Mass, length, time, and Planck units. We went to the absolute limits. That's an incredibly huger number. 3.628 times 52 watts. The other one is, where are we? Oh, yeah, that's negative 29 watts. What is that the equivalent? I don't even know. Let's go to maybe voltamperes. That's really small. It's a very small amount, but essentially it's supposed to happen. Now, why am I saying all this? So why I phrase this: do black holes ever actually evaporate? Do they ever? I have no idea. I'm pretty agnostic. I believe that's still speculated upon within a lot of folks within the community. Okay, my conjecture is, okay, even if that does happen, even if you could shield it away from all the matter and everything, if space-time in and of itself, space has energy in it, and at least technically we have, let's say, utilizing scientific units within the metric system, we have the ability to convert space into mass. At least that's what I'm kind of getting from the Wolfram Physics Project. Essentially, you have atoms of existence. I'm particular to the name they gave them, EAMS. It's pre-mimetic, literally. But my thing is, okay, there's energy in space-time. You have the ability to convert it between time, space, mass, charge, and temperature. Because essentially, this is what the radiation is. It's a very small amount. Technically, it has a temperature because it's radiation. It's radiating. It's literally in the name. But, okay, how about if rather than other stuff coming around, do black holes eat space-time? I mean, again, I am not a professionally trained cosmologist nor physicist. I'm a dude on the internet. But essentially, if we already know there's energy in space-time via vacuum fluctuate. See, I tend to gauge things due to the amount of hand waving. We're trying to account for the fabric of reality itself. I mean, who would have thought that's a difficult thing? It's amazing how much the platonic solids keep coming up. I'm just saying, different neurons are firing right now. This is making me happy. Hey, Whitechapel. Good to see you, my friend. Black holes, technically, thinking like probably trillions of years or so. Like in some of the models, it's like, all right, if you're gonna have a big crunch, or if everything's eventually just gonna radiate, i.e., it's what is it, like 10 to the 100 years? It's a ridiculous high amount. Is that about a Google? No, it's 1 followed by 100. Yeah, that's about a Google. Give or take a 10 orders, an order of magnitude, which is basically 10 times more. It's easy for our human brains to kind of keep track of things. At least we try. But my conjecture is, are there just quantum fluctuations going around causing the Hawking radiation? Or if we're looking around it, I think it's something Professor Wolfram, I should have linked to a stream, he was discussing a little bit earlier. It's like, well, at first we thought the luminiferous ether. Apparently, I believe the Maxwell equations, Mr. Dr. Professor Maxwell wrote them assuming luminiferous ether. Apparently, the was it the Milgram-Molly experiment? They were measuring for ether drift around 1900. They didn't find it. There's no luminiferous ether. Jump ahead about 80 or so years, we're looking at maybe perhaps superfluidic or something of that model. There's some form of a medium. It kind of sounds like the ether. I'm not saying we need to call it the ether. It kind of, I think it's the ether. However you want to characterize it, whatever. We just need some terms we agree upon. But if that's the case, if it's literally like a maelstrom, kind of like in Pirates of the Caribbean 3, now, I'm not saying Orlando Bloom is going to pop out. It'll be a happy surprise. No Orlando Blooms were harmed in the making of this movie. But personally, I'm a Captain Jack fan. I passed totally modeled D&D character after him. But now, what I'm saying is, okay, so if this is a thing, if there's literally a medium, if it's literally sucking in space-time, will a black hole ever actually evaporate? Even if it is emitting this Hawking radiation, maybe that would increase, but it's a really small number compared to like the mass and I'm just saying, is it in space-time? And may that account for, what was it? I think Dr. Becky or something covered. I should have linked. But apparently there's a black hole that grew enormously by just eating dark matter. Essentially, we couldn't see it. I'm just saying, maybe possible that, I don't know, the space-time and areas of matter via gravitational effects and everything. Welcome, Bone. Good to see you in your kitty form. Those effects literally are energy within the vacuum. And if gravitational effects take part, because E equals mc squared, but here's the thing. There's other things, other equations in that. We just assume rest mass. And apparently, at least according to some smart people, if we're never actually still, because we're in the Earth, rotating around the sun, and an arm of the Milky Way, about like 2/3 or whatever, out there, hurtling through the cosmos, I think there's some motion going on there. I'm just saying that if black holes are eating space-time in energy-dense regions literally has more energy in it, wouldn't that also help explain dark matter effects? Because apparently, I could just say, well, if quote unquote our universe, our realm of persistence is greater than 14 billion years old, you just have more black holes and stuff. That's an easy fix to the model, but you're assuming the Big Bang is a localized event. Again, do I know that? No. Have I conjectured that? Sure. Again, this is conjecture. This is just stuff putting out there. Some folks have some commentary on it, and it's constructive. That's totally cool. But all I'm saying is, if black holes are eating space-time itself, and that's greater than the amount of Hawking radiation, if it irradiates Hawking radiation that is irradiated, do black holes ever actually evaporate? God, I blow you over 12.5 minutes. But, well, here's the thing, Whitechapel. Callie, there are some models, apparently, if it's evaporate, it may stay the same, it may have the same event horizon, even. It's weird. It's weird. That's why I'm like, I listen to neutron decay cosmology. I'm like, what? Explain what? But again, you're also going to need some observational evidence. It's going to require more experiments. Do we need a bigger collider? Do we need better colliders? And maybe some more human consciousness on that. But that's all I got. We'll go out the same way we came in. But be sad, everybody. Be safe. And you know what makes me happy?
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one rule he had. I don't think it rules them all, and it might be just hyper-rurial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrurial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
I believe that's the final parsec problem. Peace.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.